Hello there. Merry Christmas to you all, and welcome to my session for this year's Festive Tech Calendar. This is the first time I'm delivering a session for the Festive Tech Calendar, and I'm very thankful for the opportunity. My name is Haflidi Fridthjofsson, and today we are going to talk about how we can deploy scalable container apps jobs within Azure Container Apps environments to host self-hosted Azure DevOps agents that can deploy and manage infrastructure within a private network. If you don't know me, as I mentioned, my name is Haflidi Fridthjofsson. I'm a principal cloud architect and a Microsoft Security MVP. I talk a lot about secure infrastructure, cloud security, and infrastructure as code, and I'm also one of the organizers of the Microsoft Security User Group. I've been an IT specialist since 2011 and a Microsoft certified professional since 2014. You can find me on my blog at azureviking.com and follow and connect with me on LinkedIn, and then on GitHub, where you'll find few Terraform modules that I've created and all the sample code for this session as well. So let's get started and talk a bit about, first of all, what is Azure Container App Environment and why do we want to use it to host our Azure DevOps agents? So when considering built agents to use in Azure DevOps, we have two main options to consider. Either we choose a Microsoft hosted agent, which is fully hosted and managed by Microsoft, or we choose a self-hosted agent. Agents that we have full management over, can configure however we want, and are normally hosted on a virtual machine. Microsoft hosted agents can be used for most things, but in some scenarios you may need to talk to internal company resources that are residing, for example, within a private network, or as security is a really concern for your company, which is when we would need to consider self-hosting the agent ourselves. However, there are some pros and cons when it comes to running self-hosted agent versus using the Microsoft hosted agents. Some of the pros of running a self-hosted agent are that we have more control over the environment. We are able to install dependent software needed for builds and deployment, and we are able to communicate to internal resources that are behind a private network, which is often needed when communicating with storage accounts, key vaults, and other resources that do not have a public endpoint available, or are restricted by having a public endpoint available. However, the cons are that we need to maintain and upgrade those agents ourselves. And then versus when using the Microsoft hosted agent, the pros are that the agents are maintained and upgraded by Microsoft, and each time we run a pipeline, we get a fresh virtual machine that is discarded after one use. We have predefined Azure Pipeline Agents pool that offers several virtual machine images, each including various tools and software. Though it's difficult to use these agents to communicate with internal networks, they're run on a secure Azure platform. However, they're not run within our virtual network. They're run, of course, within Microsoft's backbone. However, the cons are that you have less control over the environment. You cannot install dependent software needed for builds and deployments, and machine level caches are configurations do not persist from run to run. Like I said, self-hosted agents give you more control over your environment, allowing you to install dependent software needed for your builds and deployments. But as Azure DevOps pipelines come and go, as they complete each task required, you want to be able to scale the agents out as required and pay only for what you use. One might consider that Azure Virtual Machine scale set agents could fulfill that requirement, and certainly they actually can. However, you still need to maintain virtual machine images and storage, They are often slow to provision and start, and they could become inconsistent as manual changes can be easier to do. As I mentioned in introduction, and as I mentioned in the introduction, we are going to achieve this by deploying container apps jobs within a container app environment. There are some pros and cons when using container apps jobs for this kind of work, and that is you can run containerized tasks that execute for a finite duration and exit, allowing you to perform tasks such as data processing, run in deploying infrastructure as code using Terraform, like we are going to demonstrate later on, or any scenario that requiring on-demand processing. Container apps and jobs run in the same environment, which allows them to share capabilities such as networking and logging. However, you have less control over the environment, and you cannot install dependent software needed for builds and deployments. Additionally, same as goes with Microsoft hosted agents, machine level caches and configuration do not persist from run to run. But so, what do we need to deploy these, to be able to deploy this this environment? So what type of resources are needed when we're deploying this environment? So, our infrastructure for the Azure DevOps self-hosted agent environment will consist of resource group to gather our resources together. It will consist of user-assigned managed identities for managing the infrastructure, authenticating to several resources, and to add the agent to the agent pool without using personal access token. It will also contain an internal container app environment. It will contain a virtual network with two sets of subnets, one for the container app itself, and one for other shared services like Key Vault or storage accounts. This subnet is basically there to be able to use private endpoints later on. But in the demo, we are just going to use service endpoints and not private endpoints for ease of use. We're also going to deploy a Azure container registry to host our agent image. In addition to that, we need to deploy an Azure Key Vault to hold a personal access token that we need to create in the Azure DevOps environment because of the KEDA scaler. So the KEDA scaler only supports today a personal access token in DevOps to be able to listen to the queue in Azure DevOps, but and it's not yet supporting user-assigned managed identity. This is, however, on the roadmap at the KEDA team, and it has been committed to the roadmap, but it's there are no ETA on the release of using managed identity for the KEDA scaler and the Azure Pipeline KEDA scaler. And last but not least, we are going to deploy a deployment scripts to run the scripts to build our container image into the and publish it into the container registry and the placeholder DevOps agent within our agent pool. So these resources are built or created to host our agent container environment. For the testing purposes, we are also going to deploy a Terraform infrastructure environment, and that environment consists of resource group to gather our resources together, user-assigned managed identity, one virtual network with one subnet, and this virtual network will be peered to the self-hosted agent environment VNet to be able to utilize the service endpoints for private networking. So basically, in this demo, we are not going to use a private endpoint to connect to the storage account or to the key vault. I'm just going to use the service endpoint for now for the ease of demo. And last but not least, it's going to deploy a storage account and a container for the Terraform state files that has public access blocked, but will allow service endpoints from the container app subnet. So let's get started. If we go into the demo environment, I have created a repository with all the pipelines, all the bicep files, and everything that we need to be able to deploy the Azure container environment, the Terraform test infrastructure, VNet peering, and also a Terraform test resources. I've also created a bicep deploy PowerShell script that will actually deploy two sets of the resource groups that we talked about earlier in the slides. And we're also going to create the user managed identities with that script. In addition, this script will also deploy the bicep files to create the infrastructure for both for the container app environment and for the Terraform infrastructure environment. So first of all, to be able to create a container, we need to have a Docker file. This is an enhanced Docker file that is also available from Microsoft with a little bit of less programs and software installed, but it's based on the template from Microsoft. It will deploy an Ubuntu Linux server, Linux client, or DevOps client on a Linux 2004. It will install some updates here. It will also update some software here, and it will also install Azure command line interface and PowerShell. You can also see that it will create a user to run this environment or run within the agent. So the user will not have any privileges. So it will be a non-privileged user. It will only have access to this working directory. It will give the user appropriate permissions to the working directory, and also it will copy a script called start.sh. The script is actually the script that will actually download and create and register the Azure DevOps agent. What I've done in this script is that I've created a script by not using the personal access token to deploy the Azure DevOps agent. So normally this has been done by using a personal access token, but in this script it is using the user assigned managed identity to deploy the Azure DevOps agent. So when user assigned managed identity in Keda scaler for the Azure pipelines will be available, then this can be fully automated with a user assigned managed identity and not by using the personal access token that will actually expire and are connected to one user. So basically what the script does is that it actually finds fetches the token to use for the agent to be provisioned. It creates the ACP work folder. It has a switch for the placeholder agent because we need to run a placeholder agent to be able to have one offline agent placed into the job or into the agent pool, because Azure DevOps cannot queue another job or another agent on an empty pool. I will showcase you this. I will show this when we start to deploy. So basically, what we have done, what the script does as well, it will download the latest agent and install the latest agent into the container. It will also register the agent by providing a lot of parameters, and then you have the placeholder here. The running placeholder mode is basically skipping the running the agent, so it would stay offline and it will actually disable or create or delete all the container and everything for the placeholder agent. So it will not cost anything to have the placeholder agent there. So first of all, what we need to do, we need to make sure that we have the name of the resource group that we want to create by running the script with a switch, which is called the run only prerequisites. So it will only run the prerequisite script and only run the deployment of the resource groups and the managed identities first, because we need to use that to add into the DevOps, etc. So let's start by defining what we need to define. So basically, we define the resource group name for the Azure DevOps environment. We define the resource group name for the Terraform infrastructure environment, and also the names of the Azure DevOps managed identities and Terraform managed identity. We also define the subscription ID here and the tenant ID as well. The script will actually run the prerequisites and create the resource groups first to start with. If you run the script again, it will just check for the resource groups and run and skip the creation and you will get an information on that they are already existing, if they're existing. So it will then continue to run the bicep file bicep deployment. So now let's start by running this script. We are here in the PowerShell folder. As you see, we run the run only prerequisites. This will create two sets of resource groups and two sets of managed identities. While we wait for these two to provision, we can just take a quick look into the Azure environment, and we can see that they've already started deploying these resource groups. What the script does as well, it will actually assign the user that I did mention, user assigned managed identity, a owner permission on the subscription as well, to be able to do a privilege access on the subscription. We could do this with less privilege role assignments, but for the sake of the demo, we are just doing this in that way. The same goes with the Terraform infrastructure resource group and the managed identity. Now we've created those resource groups. We can go into the portal and check if they have been created. So now they have been created, and we can see here's a managed identity. There's called ftech call 2023 Azure DevOps managed identity. Before we start deploying the code, we need to go into the Azure DevOps environment and create our project. And create our create our agent pool. Because in the parameter file for the bicep, we need to have the right name of the Azure pool. We also need to create a personal access token that is going to be used for the Keda scaler. So now we navigate into the DevOps environment, where we will start by creating a personal access token. This personal access token needs to have a read and manage access to your agents. So we find that here in the list. That's it. Go ahead and find it here in the list. Agent pools, read and manage. We'll give this a Festive tag call 2023 doing A2 agent. And we just give it 30 days right now. Could also custom define it with a longer period or give it a longer period within the selected way. So you create this token. Make sure you copy this because this will not be displayed again. We need to go into the code and paste it here. We'll go back to the Azure DevOps environment. Close this off here. And now we need to go into the Azure DevOps organization. And it's really important to create the agent pool on the organization level, because you will be able to use these in multiple projects instead of just one. But you could also create it in one as well. We're going to give it the right name, so we are going to give it the name FTEH, so FTech call 23. Then it's going to be container app A2 agent. So we go ahead and give it the correct name. Hashtag call 23 container app A2 agent. It's really important to create this pool correctly because it's actually placed in here so it's basically utilized by the name prefix, which is ftech call 23, and then container app A2 agent. This is really important to have correct because both the deployment scripts and build scripts use this to both build their container apps and their build agents. What we can do as well is that we can go ahead and, now that's done, we can go ahead and actually deploy the infrastructure. So we are done. We have set the personal access token. We have the correct agent pool created. And now it's just one thing left to do is to run the infrastructure deployment, both for the Azure DevOps agent and for the Azure DevOps agent environment and for the Terraform infrastructure environment. So we go ahead and just run the pipeline, or the deployment script, I mean. And you can see it's all, because we have already created the resource groups, it actually has the status of already exists. So here above we had created, now it's already exists. So this will start creating the infrastructure for the Azure DevOps environment and our self-hosted environment, and for the Terraform infrastructure. So now we go ahead into the portal again. We can see that the deployment has started to run. We go into the portal. We can already see some resources here, and we can monitor the deployment. The deployment takes about 15 minutes or so. it actually creates the build for the Azure Container Registry as soon as possible. And the container app is one of the longest jobs that is run on this deployment. So basically the container apps environment. But while we wait for that, we can start by going into Azure DevOps and creating the project that we're going to use, and clone the code and replace all and create service connection, etc. But bear with me. We're going to start now creating the project for the use for the testing. We're going to use for the testing. So Festive tech calendar 2023. We will give that the name of the project. Azure DevOps will create now the project, and we can already go into the repository. And as I'm just going to do this for the ease of the demo, I'm just going to import the whole repository that I have on GitHub. This will also give me the right pipelines, etc., that we need to use later on. While we do that, while it's being imported, we can go into the project settings and we can create the service connection. The service connection we are going to use later on, and we are going to create an Azure Resource Manager service connection. And we're also going to use a new workload identity federation, and we're just going to do it automatically. Because I'm already logged into the subscription and I already have access to the subscription and everything that I need, I will do this in an automatic way. It's also possible to do this in a manual way if you have created the workload identity federation manually before you create the project or the service connection. But for the sake of demo, we will do this in automatically. So we just go ahead and click next here. We wait for the subscription to load. We give it the correct name. We can do that. And we're also just going to have it on the subscription scope level, so the whole subscription. We could scope it down to a resource group, but we're going to give it access to the whole subscription, because the Terraform code is going to be able to create a resource group, and then it needs to have a subscription scoped service connection, at least. So we will give it the name ftechcall23 service connection, and we're going to give it a grant access permission to all pipelines. So all pipelines can use this service connection. We'll go ahead and save this. So we'll set up the connection. Now we have this ftechcall service connection. What we can also do is that we can go ahead and check out the repository, and now the repository has been imported. What we need to do in the pipelines, we need to create the pipelines and have them ready before or we can have them ready while it's being deployed, while the container environment is being deployed. And we can start by just editing the pipelines, and we can replace it with the pool name that we created earlier. Just do it that way, and then we add our service connection that we also created earlier here, and we also just commit this directly to the repository. We'll also do this in this pipeline as well. This is the Terraform pipeline, so this is a bit longer pipeline. The other pipeline was for testing just the scaler, so to see if it scales correctly. So basically we're going to replace the agent pool as well. we are going to replace the service connection as well. And we're just going to find the replace here. So we can replace this with it, and we're just going to replace with your service connection here to save some time. We're just going to replace it with this text here. This is the name of the service connection that we created earlier. So now we have done the replacement here on the pipeline. So we can just commit directly to main, commit directly to main, but we could also create a pull request and do all that. The whole Git flow. But for the sake of the demo, we will just do this directly in main. We can go ahead and just check quickly on the status of the deployment and see where we are at. So it's still deploying the container apps environment. It has already created the container registry. It has already created the log analytics workspace for the container login. It has already created the key vault with the correct with everything that needs to be in the key vault, like the personal access token. And it's creating now the container apps environment. Like I said before, this is the longest one. This take the longest time. But we can continue and save some time and do something at the same time here. We can just create the pipelines that we need to create. We will just fetch them from the repository. Start by adding the scale test pipeline. Let's see that it looks correct. Save it. Just going to rename it for Geda container app scale test. Save that. Go back and we create a new pipeline for the Terraform deployment. Create the pipeline, existing pipeline. We'll find the existing pipeline that is residing within the repository. We also look at this and make sure this is correct. Ftech call 23 container app as A2 agent, and then as well, we have the right service connection here that we need to use. Ftech call service connection. Go ahead and save this. Rename this to, for example, Terraform deployment. And then we have two pipelines. One which is for the Terraform deployment test, because Terraform needs to use a state file. For you who doesn't know how Terraform works, is that Terraform needs to use a state file that is hosted often on a remote storage account, which is a Azure storage account within a container, and it's really important to safeguard these state files, because these state files can include sensitive information in clear text. So it's really important to safeguard those state files within a secure storage account, which is blocked from the internet, for example. And we are doing this here now to showcase how a storage account which is not publicly available can be deployed to and can be used for this Terraform state file. But also we have a pipeline that's called container app scale test that will test the scaler. So we'll run that multiple times to just see how it scales. What we can do next, we can check if the environment is still being deployed. That's correct. This is still being deployed. So we have been doing this for 10 minutes. It takes often about around 12 to 13 minutes to deploy. Let's see if there's something wrong here. The build agent was able to run. But often it takes a bit time to deploy. We'll just wait and see how that goes. Now it has now the environment has been done, and now it will actually go ahead and run the placeholder agent. So we can see that it will deploy the placeholder agent. We can see it has been around 11 minutes for it to run. What we can do in the meantime while we wait for this is that we can Terraform, go into the DevOps, and we can just check if we have everything that yes, of course. What we need to do is that we need to wait for the Terraform storage account to be available to be able to use to create the library group that we're going to use for the storage account name and etc. for the Terraform pipeline, because it will use variable groups to get the right information. But we can go ahead and create the environment that is being referenced within the pipeline. So we use Terraform here, just a simple naming here for the environment. Then we can just give it. We can let all pipelines use this environment for the sake of the demo. We have created the service account, we have created the agent pool, and soon we should be able to see an agent pop up here, which is called the placeholder agent, because in the deployment here it is being deployed as we speak. So we can also go ahead and check out some of the other stuff while we're waiting for the deployment. We can see that we can go into the container registry, for example, and we can see go into tasks, and here we also can see the run. So basically here we can see all the log for the agent, that because the script deployed the agent and used Azure resources to deploy the agent and create the Docker container or the container image that we are going to use for agent. So you can see it's setting up all the programs that I've listed in the Docker file, Docker file, and we also can see that it's installing PowerShell, it's setting up everything it needs, and it's preparing the agent for pushing the agent to the container registry. You can also check to see if the placeholder agent is there. We can see we have got an output here. That means that the placeholder agent has been deployed. And we can also check here and go into apps. We can go ahead and check out the placeholder here, and you can see if it has deployed correctly. So our placeholder agent has failed, and this is probably due because we forgot a step. So basically what we need to do is in the organization settings that we forgot earlier, is that we need to give the managed identity the right permissions to the agent pool, because we're using a managed identity and we forgot. So here we go. We will add this, and if this fails, we can go ahead and run the placeholder agent again. So basically we run it now and we see what happens when it runs. In a few moments it should pop up into the agent pool, and we can see the agent is already here. So it doesn't take a long time. So we basically we skipped the permission part, but that has been fixed now. So the managed identity needs to be added to the service account. It needs to be the project collection service accounts, and it needs to be added there to be able to have the right permissions to add the agent to the right pool. This also goes to the environment, to the container app job, because that also creates uses the managed identity or provision agent. So we can see execution history here. We created another container placeholder, and it was succeeded. It took 29 seconds after we fixed the error. That happens in the live demo. So what we are going to do next is that we are just going to go into the Azure environment. We're going to check out the deployment. You can see that the deployment has been successfully deployed, and you can see that every steps are now complete. It has even created the Terraform infrastructure resources and paired the virtual networks together. So what we're going to do next is that we're going to give the correct permissions first of all to the storage account for our service connection that we created earlier. I'm going to go into the access control management to add the storage account. Storage blob data owner, and we're going to add the managed identity. No, the service account that we created earlier. So this is going to be we're going to add the selected members, and we're going to add the service connection that we created earlier in DevOps. If you want to see the service connection that we created earlier, we can go into the projects, we can go into the service connections, we can click on the service connections, and we can click on manage service principals. Then we will get a new window with our manage, which gives us the right name here. We will then use this name to add a member here. So we're adding the correct service connection. Just review and assign, and this one is assigned to the storage blob data owner because this service connection needs to be able to read the storage account. Just for the sake of testing and before we test this out, you can see that I am currently not able to read inside the container because I'm not allowed to do that on my network because I'm not either within this private network here or within or have my public IP on the firewall. So we also need to go into the DevOps environment again, and we need to create a library that we are going to use with the pipeline. So we will call that Terraform. and we need to add a few variables that we're going to use. This is container name. This container is Terraform state. We'll also need to add the key name, which is this Terraform state file. We'll just call it Terraform state.tfstate. And then we'll need to add the resource group name. Let's add the resource group name here. I'll also do add the storage account name. What Terraform version we are going to use of the Terraform client, because it will be installed. We're just going to use the latest version, and that we are going to use Azure AD auth or enter ID authentication to authenticate to the storage account. So for the resource group name and the storage account name, we can just go ahead into the portal. We can find the storage account under the Terraform infrastructure, copy the storage account name, paste it into our variable group, and the resource group name as well. So now we have a completed Terraform variable group that we can use with the pipeline later on. So first things first, we're just going to test out the container app and see if it actually runs. So we just run the container app scale test pipeline on the main repository. Just click run here. We of course need to give it permission on the pipeline, and that's just one time permission that we need to do this. And just permit that the agent pool, that this pipeline can use the agent pool. We could also go into the agent pool and we can just allow all pipelines to use it if you want. So we could go in here, we can just go ahead and change the security, and we can click on open access. But sometimes you want to restrict what pipelines can use the agent. If you want to have the agent only for pipelines that are doing restricted jobs or something like that, you can just add the pipelines here from all the from within the agent pool, within from the project. But for our sake, so we don't need to. Okay, so we go ahead into the pipeline. We can see it already has spun up. It takes about few seconds for the agent to spun up, and in this time it took about few seconds for the agent to run. And we can see already, if we go into the agent pool, to the agent, the agent is gone that we used. So to showcase that it's a little bit better, we can run this pipeline multiple times. Let's run the pipeline, and then we just run it again. We can run it one more time, and now we can go ahead into the agent pool, and we can monitor the agent pool and see that now it has 3 jobs into the queue, and we can monitor if we get the agents now here. So basically what container apps jobs will do, it will basically monitor the queue that is here, and whenever the jobs are being added to the queue, it will scale up. And as long as you have parallel jobs in your private repository or your public, you can have as many of them as you want. And but you can pay for the parallel jobs for self-hosted agents. So you can see for my account, I have 2 parallel jobs. So you can see there are 2 agents that have now been spun up and are running here. You can also see that we have 3 agents and 1 is just idle because of the agent was pending, because I don't have licensing for more than 2. For this scenario, I only have 2 licenses for parallel jobs, so they run in parallel. We can also go ahead and test out the deployment by deploying the Terraform deployment. We go ahead and we run the pipeline. Just run the pipeline. I will see the Terraform code being deployed. And this pipeline will we just need to permit using the variable group as well. So it needs permission here to use the variable group and need to be permitted to use the agent pool as well. So we just permit this one time, and as well, and as I said before, you can go ahead and just allow all or allow them manually instead of just doing this. If you do not have the permission, you can get your Azure DevOps admin to allow this. So we go ahead and the job is waiting now for an agent. So we can see it's in queue. We can go ahead again into the agent pools, into the project settings. We can see that now it's in a queue. And it was just waiting for the agent to be spun up. This took about 30 seconds to spun up. So the wait time was it's really minimum to what we are seeing. So the agents are spun up. You can also see this in the portal as well. You can go ahead and we can go into the Azure DevOps resource group. We can go into agent job. And we can also go into execution history. And here you can see all the agents that has been spun up. So now this agent is running, and this is just a brand new agent that has not been used before. So the machine level cache and everything is not persistent on each agent because they're spun up. You get a new agent every time you run a job in Azure DevOps. So you go into here and go into Azure DevOps again. Go into the Terraform deployment pipeline. We can see it has started already to plan and installing the Terraform executables, running Terraform init, running Terraform validate. It runs the plan. We can also, because how this pipeline works, we can also look at the plan by how this pipeline, especially this pipeline works. We can look at the Terraform plan here. If we get it straight into DevOps, you can see it's going to create a resource group, and it's going to have a random ID on that. Okay. In the pipeline, we have a manual step to review the Terraform plan, but we can have this skipped, have this step skipped. But sometimes I like, especially if Terraform is destroying or removing, or especially destroying resources, it would be a clever way to have a manual validation there. If it's just creating or changing something, it's sometimes way more easier to have it auto-approved by having another step in Terraform applied that was actually just auto-approve it and go ahead and deploy it. It just depends on how you are setting up your environment. So now the job is pending for a new agent. What this pipeline does as well, because it doesn't have a persistent deployment, we can see it has already uploaded artifacts to use for the Terraform deployment. So we can see that it is now waiting in the line, and now the agent is here. So as you can see, it takes a few seconds for an agent to be spun up in the container app environment. And you can see it's now downloading the artifacts. It will plan the artifacts. It will install the newest version of Terraform, just to make sure, because the agent doesn't come with Terraform installed. And it runs Terraform apply now. Now we can go ahead into the portal, and you can see this was done by the agent itself. So basically, what we are doing here, you can also see that this agent is still running, but this agent will be discarded very soon. It's just finalizing some few tasks to be ejected out from the agent pool. And we can also see it's gone. This agent, just to mention again, this agent needs to be here because it can also be just disabled, and you can deploy. You can delete the placeholder container job in Azure. So basically, you can go ahead and delete this deployment script here and the placeholder resource, but these do not cost anything. But however, you cannot delete this one because this one needs to be here as a workaround for the pipeline to set a job into a queue, so the Keta scaler can pick up the queue. But we can also now see if the resources has been deployed. We just go ahead into the subscription, and we can see we have a new resource group here, which is called Festive Tech Calendar 2023 TF Test, and some random string here. We can also see it's created by Terraform, and Terraform Infra is the environment. We can also see and test that we are not having access to the container, as the storage account is behind a firewall or has denied public access. So basically, it doesn't allow public access, or it does allow public access, but it only allows the IP address that you set on the allow list or the virtual networks by using service endpoints. But you could also disable it by public networks and add private endpoints if you want. And then you would need to deploy private endpoints into the container app registry, and etc. And that's for another time. But now I have shown you how the Azure Container Apps environment works with deploying scalable Azure DevOps agents in a secure way. And by that, I would really want to thank you for listening in, and wish you a happy holidays